So it says here to calculate using the definition of a mole as a conversion factor. So we know that 1 mole is equal to 6.02 times 10 to the 23rd atoms. This question here is asking for the number of sulfur atoms in a 0.750 moles of sulfur. So we start off with the given, which is 0.750 moles of sulfur. So we want to use this as a conversion factor. So we know that we need to find the number of sulfur atoms. So we know that 1 mole of sulfur can be equal to 6.02 times 10 to the 23rd atoms. So we know we can now cancel both of these out, moles of sulfur with moles of sulfur. So now all we need to do is just multiply 0.750 moles, or 0.750 times 6.02 times 10 to the 23rd atoms. So when you plug that in, you do 0.750 times 6.02 times 10 to the 23rd, and you get 4.5, and round that to a 2, 4.52, 2 times 10 to the 23rd atoms of sulfur. And that's the answer. So the next question says to calculate the number of carbon dioxide molecules so that's going to be known as CO2 in a 0.00010, I believe there's another 0 moles of CO2. So you want to start off with the given 0.0001000 moles of CO2. So we do the same thing, a conversion factor, and we're trying to find the amount of molecules. So we know that 1 mole of CO2 is equal to 6.02 times 10 to the 23rd molecules. So now we can cancel out moles with moles, and we need to multiply this whole number here and 6.02 times 10 to the 23rd. So when we do 6.02 times 10 to the 23rd times 0.000100, we get 6.02 times 10 to the 19th. I don't know if you can see that. And that's our answer, 6.02 times 10 to the 19th molecules of CO2. That's our answer. Okay, so the next question is taking another example, the antiperspirant aluminum sulfate. So what you can do here is, so it says how many moles of aluminum are present. So since it's we start off with the given 1.5 moles of aluminum sulfate. So once we start off with that, we need to cancel it out with moles of aluminum sulfate. So we know that we can cancel it out with 1 mole of aluminum sulfate. Shut up, Nargis. So we know that 1 mole. So since it's asking for the amount of moles, it's not asking for atoms. So we wouldn't use 6.02 times 10 to the 23rd. Instead, we would use the subscript 2. So aluminum has 2, so it'd be 2 moles of aluminum. So now what we can do is we can multiply 1.5 times 2 in our calculators. 1.5 times 2, and that gives us 3. But if we want to be precise, we can do 3.0 moles of aluminum because of the sig figs, correct amount of sig figs, 1 and 2. So the next question here is how many moles of oxygen atoms are present in 1.5 moles of aluminum sulfate? So what we can do here is we start off with the given, same thing, 1.5 moles of aluminum sulfate. So what we can do is, okay, so we need to cancel it out with 1 mole of aluminum sulfate. So since it's asking for oxygen atoms, we know that oxygen has a subscript of 4, but there's a 3 on the outside, so we need to multiply 4 times 3, and that's going to give us 12 12 moles of oxygen. So that answer is going to be 18 moles of oxygen. Because if you do 1.5 times 12, you get 18. Okay, so the next question is to calculate the molar mass of each of these. So it says here there's 2 oxygens, so we know that the molar mass of oxygen is going to be 16. That's the molar mass. So since there's 2 oxygens, we would want to do 16.00 times 2. And that gives us that's going to give us 32. I don't know if you can see it. It's going to give us 32. 32.00 grams per mole. So this one here is, there's 2 aluminums, and then it says, right here, hold on one second. Okay, so since there's 2 aluminums, we know that aluminum's molar mass is going to be 26.98, so we can say that's going to be 27. So aluminum is 27. We know that sulfur is 32.07. Sulfur is 32.1, and we know that oxygen is 16. So we know that aluminum's subscript is going to be 2, so we need to multiply 27 times 2. We need to multiply sulfur, since there's 3 of them, because of the parentheses, it would be 32.1 times 3. And then for oxygen, it would be 16.00 times 12. So once we do that, we do 27 times 2. So 27 times 2 is going to be 54. 54.00. We know 32 times 1, or 32.1. 32.1. Oh my gosh, times 3 is 96.3, or just 96. And we know 16 times 12 is going to be 192. Okay, 192. So now all we need to do is just add these all up together. So 54 plus 96 plus 192 should give you 342 grams per mole. That's the molar mass of these 2 problems here. So now I'm switching up a little bit. We're going to use the molar masses from question 3. Use the molar mass of from question 3, and we are going to calculate the moles and see how much they weigh in grams. So we start off with our given 0.25 moles of oxygen. So we know that oxygen, that 1 mole of oxygen, 1 mole of oxygen weighs 32 grams. So since it's asking for how much grams it weighs, for what it weighs in grams, we can cross these out. 1 mole of O2, cancel those out. We just do 0.25 times 32. 0.25 times 32 gives us 8. To be precise with sig figs, you can just do 8.0 grams of O2. The next one 0.00100 moles of aluminum sulfate would weigh how much in grams? So we start off with a given 0.00100 moles of aluminum sulfate. We know we need to find moles, so we're working what am I doing? Oh no, sorry. We're okay, so I'm sorry, I messed up there, but so you do this here. So this is asking how much it would weigh in grams. You want to cross cancel it with moles of aluminum. So you cross this off, and we know that 1 mole of this whole thing right here, this whole thing equals 342.17 grams of aluminum 224. So we cancel both of those out and we multiply these two numbers together, and our total is going to be 0.342 grams of aluminum. Shoot. Okay, so this one, oh my god, this stupid ant. Okay, so this one says we have moles of oxygen if you weighed out 0.5 grams of oxygen. So we start off with the given, which is 0.5 grams of oxygen. So since we're trying to find moles, we know that oxygen weighs 32 grams, so we put 32.00 grams of oxygen. So we're trying to find moles, and we can do it over 1 mole of oxygen. So trying to find moles. So we cancel out grams and grams. So we do 0.5 divided by 32, and our answer is 0.02 moles of oxygen. Okay, and then our last question for today is to balance one of the equations. This equation here. So we know that we have phosphorus. Is that phosphorus? Yeah, phosphorus, I guess. So phosphorus, oxygen. So we know that we have these two elements, right? Elements. And so on this side we have four of these, 4 phosphorus, and then we have 2 oxygens. And then on this side we know that we have 4 phosphorus, and we know we have 10 oxygens. So we know that both the phosphorus is balanced, but we notice that the oxygens are not balanced. So what we can do here is on this side we can multiply this oxygen, this 2, with a 5, because 5 times 2 gives you 10. 5 times 2 is 10. These both balance out, and these two balance. So you can just put a 1 in front of these, because we have 4 phosphorus, 10 oxygen, 4 phosphorus, and 10 oxygen on this side, and that's it.